Thanks everyone for tuning into this session. I'm excited whenever I get the chance to talk about Iceberg. So thanks to the Dromio team for having me here today. So at this conference, the Subsurface Data Lakehouse Conference, you're going to hear lots about data lakehouse, table formats, specifically about Apache Iceberg. And the chances are that you've probably come across or heard of, or even are using another table format in the form of Delta Lake. So what my goal is that after this introductory level session, that you're going to walk away with some basic understanding of some ideas to consider for different approaches to converting from Delta Lake to Apache Iceberg. So we should be able to see the slide. So here's an overview of how we're going to go about doing that today. So first, just a quick recap, quick summary. Most of you probably know about Delta Lake and Iceberg, but in case you don't, we'll just do a quick summary of the two. And if you're interested in doing a deeper dive on either of the table formats, there's lots of information, documentation online, and also other sessions at this conference. We'll go through a summary of the different strategies that you can take to convert Delta tables into Iceberg format. I'll share a simple demo of these different strategies hands-on, and I'll save time for a few minutes at the end for some live Q&A. And before we dive in, I think the first thing that I want to cover is why are we talking about these things? So, and why are we talking about specifically converting Delta Lake into Iceberg? So Delta Lake and Iceberg, both really interesting technologies. Each of them have advantages, disadvantages, and great for different use cases. Ultimately, you should be choosing the tools, the table formats, the architecture that best serve your needs and use cases. This session is going to be most valuable for people who are maybe learning about Iceberg, find it intriguing, curious what a potential migration could look like, or those who are thinking about using Delta Lake, but also want to make sure that you have an exit strategy in the future if need so. So first, let's walk through the two different table formats. So like I said, some of this stuff you might already know, but just to level set on how Delta Lake works, every modification to a table, so inserts, updates, deletes, they essentially add and remove files. They're a update metadata, and they generate what's called a new commit to keep track of how the table is changing. And those commits are stored in what's called a Delta log, which is in JSON file format. After a few commits, Delta Lake summarizes this into what's called a checkpoint file in Parquet file format. And all of these commits are essentially metadata describing the changes to the actual underlying data files, which are stored as Parquet. And in an architecture without a catalog like Glue or Hive Metastore, engines are relying on the folder structure to locate and address tables in order to operate on them like reads and writes. And Iceberg is similar to Delta Lake in that where they are similar is that both are trying to create abstraction in order to provide ACID transactions, time travel, pruning, all the metadata operations. But here, let me just describe what Iceberg does and how it's a little bit different. So with Iceberg, there's multiple layers of metadata. So at the top in this figure on the right here, there's the catalog to keep track of tables and their locations. To make sure that engines know where tables are located and how to address them. Then there are metadata files that keep track of the table schema, partitioning, properties, and snapshots. There's the manifest list that keeps track of the various manifests, the partition stats, file counts for pruning and query execution. Then there's the next layer down, which is manifest files, which is essentially just a list of data files, partitions, and summary stats. And then at the lowest level are the actual data files, which you can think of what you would, if you were to query a table, these are the things that are the actual fields and rows and columns and values. But like I said, they're both Delta Lake and Iceberg similar in that they are trying to use metadata to create some abstraction of from the data files to into tables, and that's how they're able to provide ACID transactions, time travel, schema evolution. But that said, there's a few, in my opinion, I think there's a few advantages to using Iceberg. One is that Iceberg doesn't depend on the table's physical layout. So Iceberg tables can evolve partition schemes over time through metadata only operations. Another is that Iceberg keeps track of relationships between partition columns and transformations. So like filtering by date time value, even though the table is partitioned by date. And this functionality is what the Iceberg community has come to know as hidden partitioning. And lastly, with Iceberg, Iceberg is an example of a really thriving open source project. So your use case calls for an open source table format, and you probably want to implement an architecture that you can trust for the foreseeable future, right? The ecosystem that is around Iceberg and that continues to grow. It's already quite large and rapidly growing. It's a signal of the shelf life that this project is going to have and the longevity that it's going to have as a meaningful and important part of your overall data architecture. And so much credit for that reason, so much credit is owed to the founders, the Iceberg community, the contributors, and ASF for supporting this project. So that's just an overview of the two different table formats. Let's walk through a couple of why or how you might convert from a Delta Lake table to Iceberg. So at a high level, and credit to Alex Merced, who's on the Dremio team, I've seen some of his content and thought that he does a really good job of summarizing a lot of these concepts. So here's a high level process of what a conversion would look like. So phase one, kind of status quo if you're using Delta Lake today. You're reading and writing to Delta tables. Phase two is that you created an Iceberg target table so that all the new, and you're making it so all the new writes are going to both the Delta and the Iceberg tables to get them synchronized. And for the time being, you're still using your Delta table for the production reads. And phase three is like essentially flipping the switch where both of the tables are synced up, the Delta and the Iceberg table. All the reads are now pointing to the Iceberg table, but underneath you're still writing to both the Delta and the Iceberg tables, checking it for doing quality assurance. And the Delta table is there in case there's any need to roll back from the new Iceberg table. In phase four, everything looks good. You only need to write to the Iceberg table now. And you can read, and all of your reads are already happening on the Iceberg table. So let's take a closer look at specifically phase two for how to actually create the Iceberg table from the existing Delta table. So there's a couple different strategies on how to do this table conversion. Each method has its different trade-offs, and it's important that you make the decision of what matches the needs of your use case. So the first, which is the top row of where you're actually copying and rewriting data. And so Dan Weeks, one of the Iceberg co-creators, called this the brute force method, and Alex Merced called this the shadow migration, where you're basically reading the entire Delta table and you're writing it out as a brand new Iceberg table. Now, it may seem less than ideal to pay for the compute involved in writing all those new data files. So all those Parquet files being rewritten into the Iceberg table. But as part of that, you get all of the column IDs that are generated. And so what that provides is all the awesome benefits of Iceberg. You get clean, reliable schema evolution, partition evolution, hidden partitioning. You get all that stuff very easily. So overall, this one, very clean approach. The second is what Alex calls the in-place migration, where you're actually not copying the underlying data files, and you're just using the Parquet files as they are from the Delta table. So pretty obviously, the nice thing is that you don't have to rewrite all those Parquet files, but the downside is that you didn't rewrite all those Parquet files. So you save some of that money up front on the compute, but it could lead to headaches and pains later without the optimizations that Iceberg can provide. And plus, you don't have that clean column ID mapping that is what enables safe schema, partition evolution, and all those metadata operations with Iceberg. So this is mainly focusing on the conversion of data files. And like I covered in the iceberg diagram earlier, there's that catalog component to it, right? So let's talk quickly about catalogs in this migration. I'm not going to do a deep dive on the different catalogs and compare which one to use when. I simply wanted to provide a pretty high-level summarized list of what the different options are, all by which to illustrate that there's lots of options with Iceberg, and you have options with Delta Lake as well. So if you're using Hive Metastore with Delta Lake, you can stick with Hive Metastore and Iceberg. If you're using Glue Catalog with Delta, you can stick with Glue Catalog and Iceberg. If you aren't using a catalog with Delta, there are lots of options to choose from in terms of which catalog to implement. And I will also call out that the Hadoop catalog with Iceberg is essentially relying on the file system. So it's about as close as you get to having no catalog as with Delta Lake, also relying on file system. If you're not using one of these catalogs, Hadoop is probably the closest on the Iceberg side. But with all of these Iceberg catalogs, each one has inconsistent implementations, and you might want to make sure that accessing Iceberg tables from different clients follow the same rules. So to address this, the Iceberg community has created what's called a REST catalog implementation. More to come on this. I know that the community is hard to work on this. I would expect to see that the community, the Iceberg community, focus on this into the future to get that consistent experience. And then now we're at the demo portion. So I will now play a quick little demo showing these different conversion strategies in action. Okay, so in this demo where I'm going to show you how to convert a Delta Lake table into an Iceberg table, let's first take a look at what tools I'm using. So first you see here, I have an S3 bucket located in AWS US West 2. And like I mentioned before, there's some pretty handy procedures with Apache Spark and Iceberg. So I'm going to be using EMR, an EMR cluster, version 6.9.0, running Spark version 3.3.0. And I've configured my cluster to have Delta and Iceberg enabled using their default properties, or sorry, their default versions. And those versions happen to be for Delta Lake 2.1.0 and Iceberg 0.14.1. And I'm going to be using Iceberg SQL extensions. I've disabled the Delta safety check that will allow me to vacuum the entire table, the entire Delta table, to get only the latest version of Parquet files, which you'll see where that comes into play later. And for simplicity, I'm just going to be using a catalog type Hadoop. I'm calling the catalog demo. And I've specified that the warehouse is located, for the Iceberg table, is located at this S3 path. So with that, let's jump over to the notebook where I'm actually going to be running the Spark jobs. So I already have the Spark application running, so we don't have to wait on that. But as you probably noticed just a moment ago, this S3 bucket is empty. I don't currently have a Delta table to convert into an Iceberg table. So let's just create a simple little Delta table using the range method to write that into a data frame called data. And then I'm writing the contents of that data frame out to a table in the format of Delta, and saved that table in Delta format to this Delta table prefix. So Spark is working away, created that data frame and wrote it to a Delta table at that location. And now let's just read the table. So here I'm reading the table. I'm specifying that, hey, this table is in Delta format and it's at this location, and let's see what the contents look like. Simple little table, one column, few integers, great, just like we expected. And in case you didn't believe me before, here I just refreshed the bucket, And here we have all the data, metadata, a couple Parquet files, the transaction log for Delta table. Great. But as you'll see in one of the future in method 2 for add files, we'll need to get to the latest version of the Delta table. So just for the sake of simulating a new transaction or multiple transactions to a Delta table, I'm again going to be using the range method. And let's just actually modify this to from 0 to 10. So I have the range method. I'm putting that into a data frame. And I am writing the contents of this data frame to a Delta table, same S3 location, and I'm specifying to overwrite the table. So while this is working away, as you saw a moment ago, there was just one JSON file, and now there are two, which means that there's a new transaction. And if I go back, there are more Parquet files. So just as expected. And for just so you can see the actual, that I can read the table, let's just see that what the table looks like. There you have it. Same table, a few more integers. Great. So we have the Delta table in S3. Now we want to convert it into an Iceberg table. We already saw that there are multiple commits in the Delta log, 2 JSON files. We already read the table. So what we're going to do is we're going to read the table, the Delta table, into a data frame that I'm just calling df_delta. And then I'm writing out that df_delta into the table at this location, which is the demo catalog, database just called db, and a table named iceberg_ctas. And I need to create that table, so I'm using the create method. And then so like I described earlier, this is reading the full Delta table in its latest version and writing out to a brand new table in Iceberg format. And just to show that it looks exactly the same as when we were reading in Delta format, now I'm reading from this location, but in Iceberg format. And just to prove it to you, if I go back to the bucket, there's this new Iceberg tables prefix. And if I click through, I have the DB database, Iceberg CTAS table, and there are my data files in Parquet format, and there are my metadata files. Great. So I just showed you in the S3 user interface, but I could also query this this files location and just basically read out all of the file paths for the Parquet files for the respective Iceberg table. So here we have it. There's Iceberg tables, DB the database, Iceberg CTAS the table, and that's the paths of all the Parquet files for that table. So in that method, to summarize, I created a few Parquet files and created a table in Delta format. I read the contents of that entire Delta table, and I wrote them out to a brand new Iceberg table, so a brand new set of Parquet files in this location. Now, what if I didn't want to write out brand new Parquet files? What if I was maybe more cost conscious? I cared less about schema and partition evolution in the future, and I just wanted a simple methods to say, hey, I already have Parquet files for my Delta table. I would love it if I could just put layer Iceberg metadata over top of that. So to do that, first I need to, like I said, I have those Parquet files as part of the Delta table. I still have that df_delta data frame. I'm just going to use that data frame to write a new table, and I'm calling it Iceberg add files. I'm creating a new table, and I'm just reading basically the header row. So I'm just essentially copying the schema as defined from this data frame, and from that creating basically an empty Iceberg table. And I can even show it to you if I did a spark.read.format Iceberg and load at this location that I just specified. Just an empty table. No records, just an empty table with a field called ID. But we have, if you recall from the Delta table, we have a few transactions. So if I go in the Delta log, there's a few transactions. So imagine if I had lots and lots of transactions, which means that Delta is writing more and more Parquet files. Well, I want to make sure that I'm not adding old Parquet files into the new Iceberg table. So what I need to do is I need to vacuum the Delta table, and I'm going to vacuum at this location. I'll go ahead and kick this off and I'm specifying a retention period of 0, which is basically, hey, I'm telling Spark I only need the latest version of the table and clean out any other Parquet files that aren't part of that latest version of the table. So that later when I'm adding those files to the Iceberg metadata, when I'm pointing Iceberg to those Parquet files, I'm making sure that I don't have any extraneous Parquet files in there. So here I've vacuumed the table. Now let's go back and check out what probably half the number of Parquet files, which is a good sign. It means that it is an indicator that the vacuum worked like I wanted it to. So now we have this procedure called add files that I described earlier. And what I'm going to do, well, I just go ahead and kick this off. I'm telling this procedure, I'm specifying that the table that I want to add files to is at this location, that empty table that I created earlier called Iceberg add files. And the source of those files that I want to add to it are at this S3 location in Parquet format. So that procedure ran, and then I also just did a simple SQL select on this add files table and show me the results. And here are the results, just like they looked from that df_delta data frame. In the latest version of that data frame, not the initial version where we just had a few integers. And to show you that, I know it's maybe not terribly obvious that you're just trusting me that the Parquet files are still in the Delta path, that we didn't write out new Parquet files. We can do that in a couple ways. One, let's go check out the UI. Or in the S3 UI. So I have Iceberg tables. There's my DB database. Let's check out the Iceberg add files. Notice that there's only metadata. There's not a data folder like there was in my other Iceberg table, an Iceberg CTAS. There's not a data folder, right? So I can also verify that by doing a select on the files themselves, just like I did earlier, where earlier I had these Parquet files at this location. What I would expect to see here is that the location for these files is actually, like expected, in the Delta table location. So these Iceberg, I'm reading the table in Iceberg format, but the underlying Parquet files I did not rewrite at all, and I'm just using the files at these locations. So there you have it. There's a quick demo. Very, very simple demo where we showed the two methods. One where we did the CTAS method where we read the entire Delta table, wrote it out as an Iceberg table. And we also showed the second method where I don't rewrite any of the Parquet files and I just add files to an Iceberg table. So now let's jump back over to the slides to close this out. Alrighty, so that was a fun demo, and that's pretty much all we have time for today.